Hello everyone and welcome to a new tutorial on the channel. Today we will talk about the mesh analysis. Mesh analysis is an important technique as what we did previously with the nodal analysis. It's very important to solve circuits. In my opinion, I prefer mesh analysis rather than nodal analysis because mesh analysis is faster, is easier, and more comfortable when you solve bigger circuits. So today we'll talk about the mesh analysis explanation. Then I will give you a shortcut method that I believe you can make mesh analysis even more faster. Then we will move on to the supermesh. Supermesh also is important as we had the supernode. Also there is a supermesh, and of course we will solve some examples. Then in the end I will put some solved practice so you can download this file. Of course I will put it in the description. You can download this file and you can practice these examples and of course improve your education. So first of all, let's understand the difference between a loop and a mesh. Of course, there's not a big difference, but you have and we have to understand the difference between the loop and the mesh so we can understand more. So in the circuit here, it's very simple circuit. How many meshes we have and how many loops we have. Actually, as we see, this one is a loop. Let's change the color so to make it easier to see. This one is a loop. This one is a loop. And also this one is a loop. Okay, so any path that starts at a point and returns to the same point is a loop. So we have three loops. Okay, but how many meshes we have? Now this one is the important. How many meshes we have? First, this one is a mesh, and also this one is a mesh. But the outer one is not a mesh. So we have two meshes. Simply listen to me carefully in this one. Any loop, I defined the loop previously, so I said the loop is a path that starts at a point and returns and closes at the same point. So in the loop I start from here, I go all the way here, here, and here, and I close and return to the same point. So this one is a loop. Okay, this one is a loop. But the mesh actually is a loop. So any mesh is a loop, okay? But not any loop. It's an advanced level of a loop. So a mesh is a loop that doesn't contain a loop inside it. So you see? So to make it easier, the mesh is the smallest loop, okay? So this one is a loop, right? But does this loop have another loop inside it? No. So this one, a loop and a mesh. This one also. This one is a loop, but does this loop has an inside loop? No. So this one is a loop and a mesh. But when you talk about this one, we start at a point and we return to the same point, so it's a loop. All of us agree that it's a loop. But does it contain a smaller loop inside it? Yes, it contains two loops inside. So this one is not a mesh, it's only a loop. Okay, this point is very important. So in short, every mesh is a loop, but not any loop is a mesh. Okay, you can play back this sentence as many as you can until you understand my point. So of course you ask what is the difference between, okay, why we understand these two? Because mesh analysis depends on meshes. And there is nothing called loop analysis. Loop, we can use the loop when you use KVL. Even though also mesh analysis depends on KVL like 90%, but it's still its analysis. It doesn't mean that I will use KVL and it's done. No, there is more analysis and procedure. And in any loop, I can use KVL, okay? In any loop, I can use KVL. In the mesh, also I can use KVL, but in the mesh, also I can use the mesh analysis, which is what, which is our topic today, okay? So let's get started. So I will give you a circuit. So of course, when you have a circuit like this, let's give you a circle, okay? So this is a simple circuit. If the circuit is like this, you don't have to use either the nodal analysis or mesh analysis. You can solve it directly. Of course, if you have the value of the battery, for example, it's 10 volts, and this one is 5 ohm, you can solve it directly without mesh and node analysis. You can find the current. But if there is a resistance here, and there is another battery here, and it is, let's say it's 5 volts, okay? I'm sorry, let's put another resistance here with 10 ohms, and one here with 2 ohms. And I asked you to find the current passing here. Let's say it's I1, and the current here, which is I2. And of course, I just followed the convention that the current flows from the negative to the positive, from negative to the positive, okay? But it may be I2 comes with me with negative sign, which means from positive to the negative opposite direction. So this one is really no problem with it. So we have to be flexible with it. You can put any direction for the current, then you check the sign of it. That doesn't mean if I found the current I2 is -5, for example, that I have to change direction of I2, then this one will be +5 amps. No, you don't have to keep it negative. No problem with the negative current. No problem at all, okay? So in this scenario, if I ask you to find the current I1 and I2, okay, you have two options. You can use either nodal analysis or you can use mesh analysis. But if you use the nodal analysis, that means that you have to find the nodal voltage. And where is the nodal voltage, which will be here? Let's say it's V1 or Vx, as we have only one node. If you use nodal analysis, that means you are solving for voltage, nodal voltages. Of course, you can, from that voltage, you can find the current. But first, you have to find the voltage. But if you use the mesh analysis, it means you are solving for current. From this current, you can find the voltage. So, to make things faster and easier, if I give you a circuit and asked for a voltage, it's better to use the nodal analysis. Why? Because nodal analysis gives voltage first. If I give you a circuit and ask for the mesh current or this current actually is also called the mesh current because it passes through a mesh, and I2 also called a mesh current because it passes through a mesh. What about this current? This current easily and obviously, as an engineer, you have to use something called KCL in this node. In this node, you will use KCL. Then you can find this current very easily. Let's say it's IX. Okay. So as we see, the arrows come here, and this one is the I2 is coming inside, and I1 is coming inside, and IX is leaving. So I can say that IX using KCL, which is Kirchhoff current law, IX is equal to I1 plus I2. Okay, so here in this one, I can find all currents. So to keep it short, to not confuse you guys, if you are asked to find the voltage, it's better and put 1,000 line under the word better. That doesn't mean that you have your should and could and must. No, it's better for you. We are engineers. We don't determine a specific way to solve problems. We have thousands of ways to solve a problem, but we choose the fastest and the best economic way to solve our problem. okay? So if you're asked to solve a nodal voltage, it's better to use nodal analysis. If you are asked to find a current, it's better to use mesh currents. And as I said, sometimes in a problem, and this one happens most of the time, you are asked to find a voltage and a current. Isn't that right? So you can, in this way, you can use one of the two ways. In my opinion, if I'm in your shoes, I will see the circuit. If it has more voltage sources, if it has current sources, this thing can be seen when you solve a lot of problems. In addition, I can make a video that compares between nodal and mesh analysis and tells which method to use when you have a circuit. If you want me guys to do this video, just tell me in the comments and I will happily make a video that compares with the two techniques and the two analysis methods, which are nodal and mesh analysis. So in this circuit, we are asked to find the currents. When you are asked to find the currents, it's better to use mesh analysis, okay? So now let's redraw this circuit in another page and try to solve it and see how things go, okay? Let's say that I have a battery, then a resistance, then another resistance, then a battery, and a resistance in between. Of course, there is a ground. Sometimes you don't have to draw the ground because you are in a high level, okay? So don't forget to redraw it. Even I'm not in a high level, so of course I will redraw it. Let's put this one here. And let's give this one a 10 volts. Let's give this one a 2 ohm, and this one is like, let's give it 5 ohm. Let's give this one, it was 10, let's give it 10. And this one, let's keep it 5 volts. Let me explain something important here. In the mesh analysis, in convention, just a convention, okay? We make all mesh currents in the same direction. So either I say that sometimes I refer it using small I, sometimes I refer it using capital I. It doesn't matter, all are correct. So let's call this one I1, and the direction of it's like this. And let's call this one I2, and the direction of it's like this. Also, you can call this one I1, and the direction of it like this, I2, the direction of it like this. It's just a convention. So the question here comes, can you make I1 goes to the left and I1 goes to the right? It is possible, but as a convention, we make things easier by making them all in the same direction. In my opinion, I used to make all mesh current directions in the clockwise. I used to solve it like this, and actually I find my reference book that I use in my slides or in my documents, which is Fundamental of Circuits, is very very good. It's very amazing book, and this book uses this convention. Okay, I put that book in the previous video, and I will put it again in this video because all the problems that I put in the end of this document I took from there, so I will put it as a reference, and also you can take that book if you want to. And if you want me to upload this video for you guys, let me know in the comments. So just for my opinion, I just follow this convention, okay? And it's up to you guys, but it's better to follow this convention, and you understand when I say it's better for you guys, okay? So now we will use KVL. What is KVL? So we will follow a loop and we will note everything. So in mesh 1, when I call this one I1, that means this one is mesh 1, okay? Because this is the mesh current number 1. And when I call this I2, that means it's the mesh number 2, and this one is mesh current 2, okay? So now let's start in mesh 1, which is this one. So the loop is starting going here, here, and like this, okay? The arrow goes from here and hits the negative sign, so it's minus 10. Then it comes here and to the 2 ohms. 2 ohms, remember that this one is KVL, Kirchhoff voltage law. The voltage here is minus 10. The voltage here is what? Is using Ohm's law, it's the resistance multiplied by the current. The resistance, let's put plus, okay? The resistance is 2. And how much is the current? It's I1. It's unknown, okay? I1, okay? Now let's come here. The current here is still, I'm sorry, the resistance here is 5 multiplied by the current is still I1. Now, do I finished? No, you're not finished. You have to put something important, which is because this 5 ohm also has a current passing to it. What's current passing to it? I2. But I2 is outer loop, not inside loop. So the outer loop, I'll put it in a negative sign, minus 5 I2. Okay? All that equals to 0. Of course, you remember KVL, which states that all voltages in a closed loop is equal to 0. Now you can fix this one by saying 7 I1 minus 5 I2 is equal to 10. And now you have equation A. And from mesh 2, obviously we can say, of course, you will start from here, coming through here, and end at the same point. Starting from the voltage source, in my opinion, start from the voltage source and come back to it so you don't forget when you at which point you started or what. In bigger circuits, you have a lot of things, so it's better to use the shortcut method, which I will explain after this example, okay? So, as we see here, I started at the 5 volt, so directly you say plus 5, and don't forget this point. The arrow, not the arrow that comes from here to here, right? The arrow hit the positive sign of the battery, so that's why I put plus 5, okay? Plus 5, and comes through here, and the arrow comes here, and come here, so it's plus 5 I2. The 5 has another current, which is I1 in the outer mesh, so it will be minus 5 I2, sorry, minus 5 I1, because now I1 is outer, not I2. I2 is inner, so that's why it's positive. I1 is outer, because I'm dealing with mesh 2. So when you're dealing with mesh 2, I2 will be inner, so it will be positive, and I1 will be outer, so it will be negative, okay? It's kind of straightforward when you're used to it. And here you have plus 10 I2. Of course, that's equal to, again, 0. You can fix this one again. You have minus 5 I1 plus 15 I2 equals to minus 5. And this one is equation B. Using matrices, using any method you want to solve an equation system, you can find them. This is equation A, and this is equation B. You can solve it in any way. If you want me guys, to put a tutorial for solving this matrix systems or equation systems, because sometimes you have 3 equation systems, not only it's always 2. Let me know in the comments so I will upload a video or upload a tutorial that discussing this problem. Because I don't want to solve this equation system during the video to make it longer for you guys. Then you will get bored and you will see that the video is 1 hour long. So no, I will pass this one. So I just want to make it as short as I can. So just like the last time, I just put in the description a link, and I will put it again. I'll link this link. It will open a website. It's a very amazing website. You can put the number of equations. You can put equation A and you can put equation B. Then boom, it will gives you the value of I1 and I2. But in the website, there is no I1 and I2. There is X, Y, Z, and W, I think. So you can assume that X is I1 and Y is Y2. If there is I3, you will assume that it is Z. And if there is I4, you will assume that it's W. Solving this way, you can solve these equation systems very quickly. But in the exams and these things, I don't think that this website will be allowed for you guys. So you have to practice these equation system solving. Then after this, you have I1, it equals a value amp, and I2, it will equals some value amp. And one of these two might come in negative. Don't be panic, it happens. And sometimes both be negative currents. Some students when they see that both currents are negative, they panic and they say that there's this, it's wrong or something like that. No, 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 no. It happens that both currents can be negative. Now let's assume that in another part in the question that says that find the voltage in this 2 ohm resistor and the voltage in this 5 ohm resistor. The voltage at this 2 ohm resistor is very easy. Directly applying this Ohm's law, I have the resistance, and after that, of course, I solved for I1. I have the value of I1 here. So you will say that 2 multiply, let's assume that I1 is equal to 5 amps, okay? So the resistance multiplied by the current gives the voltage, so it's 10 volts, okay? Directly, you can find the voltage at the 2 ohm. The challenging one might be the 5 ohm resistance. You know that applying Ohm's law again, you know the resistance is 5, but multiplied by the current. How much is the current? Because this one is a mix. It's a mix between I1 and I2. Just like I said before, again, applying KCL. Applying KCL at this point or at this node. So I see that I1 is entering, so it will be positive. Let's assume that I1 is equal to, let's keep it I1. I1 is entering, and the current passing through the 5 ohm resistor, let's say that it's in this direction, so it's leaving, so it's minus, let's call it IX, so it's minus IX, and I2 is also leaving, so it's minus I2, and that's equal to 0. KCL, that the summation of the current in a point or in a node equals to 0. So solving for Ix, you'll go put Ix in the other direction, so Ix is equal to I1 minus I2. So if you assume that I1 is equal to 5 and I2 is equal to 2, so 5 minus 2, Ix is equal to 3 amps. Okay, I just assume that I1 is equal to this and I2 is equal to this. And of course, don't forget to put the negative sign. So if I2 is minus 2, it will be minus minus 2, okay? So don't forget the negative here. The negative here is not always. Don't think that the negative here is always. No, the negative here because of the equation solving. Just follow KCL and whatever sign is there, follow the sign, follow the number, and solve it. It's very easy. Then you have the current of Ix. So this current is the current that passing through the 5 ohm resistance, which is this one, Ix. So the voltage through the 5 ohm resistance will be 5 multiplied by Ix, which I assumed they found it equals to 3, so it's 15 volts, okay? This is just an assumption, the numbers are not actually. These numbers are true. Solve it in a system, then you can have the answer putting here, and just you can test yourself and put the answer here. And I don't know if some of you use multism to check whether your answers are correct or not. It's National Instrument product. It's a system, software system that stimulate the circuits and gives you the answer. It's very an amazing system. I think the latest version is 14.2, if I'm not wrong. Now let's move on to something called the shortcut method. The shortcut method, I will not take a long time in it because it's very easy and it's very actually logical for you guys. The shortcut method is it's very easy. So let's assume that I have a circuit. like this. The same circuit above, okay? Same circuit. So if I have the same circuit as this one, let's say that this one is 15 volt, change it, and this one is 20 ohm, this one is 10 ohm, this one is 15 ohm, this one, let's say 100 volts. So the shortcut method is simply like this. I will solve it like I'm solving something in an exam, and you will see how fast I solve it, okay? So let's say that this one is I2, I1, and this one is I2. Shortcut method, when I go for mesh 1, okay, I will sum the resistances in mesh 1. So the sum of resistances in mesh 1 is equal to what? 25. I'm sorry, to 35. This one and this one, right? So I saw 35 multiplied by I1 minus the mutual resistance. The mutual resistance, which is 15, multiplied by the current of the adjacent mesh. So it'll be minus 15 I2 equals to the opposite side of the battery. The loop here enters the negative and leaves from the positive. In the shortcut method, you will put the sign of the leaving one, not the entering one, okay? So it's the opposite. So it will be plus 15. You see how fast is it? Now mesh 2, okay? I missed the E here. So mesh 2, directly, you will say it's 25 I2 minus 15 I1 equals 200 volts. This is equation A. This is equation B. Solve it in a system. Boom, you have I1, I2. This is the shortcut method. So the shortcut method is not, if you understand what I did in these like 2 minutes or 1 minute, you will understand the shortcut method and it will be easy for you. If you didn't understand it, I recommend you to solve a lot of problems in this normal method and come back and see this shortcut method and you will understand it, because I don't want to waste a lot of time in it, and it is very easy. Believe me guys, it's really easy. Just solve a lot of problems and this shortcut method will be very visible for you guys, okay? Now I just want to explain something very quickly before I move on to the super mesh. What if I have a mesh? Let's give you a circuit. I don't like to explain without a circuit, okay? Let's say that I have like this. Let's put something neutral here, like this, okay? So let's sum these two resistances, okay? Or let's keep it like this, keep it. And this one is like this. And here is also resistance to another current. So this one, let's say this one is 1 amp, this one is 3 amp, this one is 5 ohm, this one is 2 ohm, this one is 1 ohm, this one is 3 volts, this is not resistance, okay? This one is 10 ohms. So if you have this circuit, which method will you use? Are you going to use the nodal analysis or mesh analysis? Definitely you are going to use mesh analysis. Why? Because there is 2 meshes are known. So let's name them, okay? So this one is I1. Let's use another color. This one is I1. This one is I2. This one is I3. And the current passing here is unknown. But the current passing here and here is known. Why? Because there is a current source. Okay, so let's change the direction of this current source. I'm sorry, guys. Let's give it. down. So as we see that the current I3 is in the same direction of this current source. So directly I3 is equal to 1 ohm. Boom, you have one mesh eliminated. And the current passing through I2, there's a current source in the mesh. Okay, so that the current of I2, since the direction in this mesh, the direction of the mesh current that I assumed is the same as the current source. So I said it is directly positive. But in this case of I2, the direction of the mesh current that I assumed is in the opposite direction of the current source. So you will put a negative sign. That's only, and the number will still the same. So I2 is equal to 3 amps. And the direction of the arrow, it's opposite of the current source, so it will be minus 3 amps. Boom. You have another mesh eliminated. So, in other words, you only have one mesh to solve. And you, again, using the shortcut method, sum the resistances, which will be 11 multiplied by I1 minus 1 multiplied by I2, that's equal to what? Minus 3. And you have the value of I2, which is this one. So it will say 11 I1, and negative with negative will be cancelled, so it will be 3. 3, so it will be plus 3. Plus 3, I will put in the opposite direction, it will be minus 6. So I1 is equal to minus 6 over 11 amps. You have all three currents solved. So when you have mesh currents, as what we had in the nodal analysis, when you have a voltage source next to a node, let's say that this is a node, okay, and this is a circuit continuous here, and this is the voltage source, it's 10 volts. Since these two are parallel, the voltage in this node and in this resistance is equals to this 10 volts. I explained this point in the last tutorial. You can come back and check. So it's here the same. The currents, it will be in series, okay, but the voltage sources will be parallel. If the voltage source is parallel to something, it will be the same voltage. If the current source is series to something, the current passing through this something, it will be the same. Okay, so in this resistance is series with this current source, so this resistance has the same current as this voltage source. Okay, so it's very easy. You solved three mesh currents without the need of matrix solving system. Now let's move on to the last point of our tutorial, which is actually related to this one. Okay, so let's assume that you have a circuit like this. Okay, let's put we don't have to put a resistance here. Let's put a voltage source. But here in the middle there is a current source. So this one is 2 ohm, this one is 1 amp, this one is 5 ohms, this one is 6 volts, and of course the ground is here. So previously, if the current source is in series to the mesh, like in these cases, the mesh current directly has the same value of the current source. But what if the mesh or the current source is in the middle of two meshes? What that means? That means you have something called the super mesh. Super mesh. Okay, when the current source is in the middle between two meshes, and in this case, what will happen? You will merge these two meshes. You will assume that there is no current source in the middle. Okay, you will assume that all this is one loop, but don't mix between I1 and I2. Still, I1 is something and I2 is something. But when I say put all of them in one loop, I just meant the equation. But still, I1 is something different and I2 is something different. So first of all, you will start with I1. You will say 2 multiplied by I1 plus here 5. 5 multiplied by I2. Don't forget, because the 5 ohm resistor has I2 passing through it, and the 2 ohm resistor has I1 passing through it. So that's why I multiplied each one with its partner. Okay, so this one is I2, and of course, don't forget that's equal to what? Minus 6 volts. This one is equation A. Now just bring back the current source. Okay. Now, how to solve an equation with two unknowns? Well, you have only one equation. Mathematically, this one is impossible, as I said before. Now you can take help from our good friend KCL at this node to bring equation number B. So I have, using KCL at this node, I have I1 entering, so it's positive. I have the current source entering, so it's positive, which is 1 amp. I have I2 leaving, so it's minus I2, and all this is equal to 0. And a little bit of organization, I1 minus I2 is equal to 1. This one is equation B. Now you can solve equation A and B using system, and you have the value of I1 and I2. So in short, nodal supermesh, is gained when you have a mesh. When you have a current source in the middle between of two meshes. So in this case, directly go for supermesh. And don't forget, in the first equation, assume that there is no current source and pass through all the circuit. Not all the circuit, through all supermesh. Because sometimes you can have a supermesh inside the circuit. So, for example, you have this resistor, you have this current source, this resistor, this voltage source, for example. And here is still a resistor and a voltage source. So it's a confused circuit. It's not something directly. So in this case, you will have, I'm talking about only the supermesh, okay? So first of all, you will go through the supermesh, and don't forget this one is I1, this one is I2, this one is I3. So you will say the sum of these two resistances multiplied by I2 minus this resistance multiplied by I1 plus this resistance multiplied by I3 with plus or negative this sign equals to 0, and you can take this voltage source to the opposite direction with changing its sign. This one equation A. Equation B, you can gain it from this node. Of course, the convention is clockwise. So again, I2 plus the current source is equal to I3. And this one is equation B. And equation number C, you can have it from this loop. So using mesh analysis as I used in the beginning of the video, you will have equation C. You can solve equation A, B, C to have the values of I1, I2, I3. Okay, so supermesh is something easy. So at this point, I've finished my tutorial for today. Hopefully you enjoyed the tutorial and have benefit of this tutorial. So as in the previous video, I gave practice problems from my reference book, which is the Fundamental of Electric Circuits, the 5th edition, written by Sadiku and another amazing author, of course. I forgot his name. I will put it in the reference. I will put it in the description. So that's it, I think. So you can solve these problems, and there is the answers. As you see, the answers are here. So you can solve these circuits, and the answers are here. So sometimes, as you see here, that I2 is totally 0. There is no current passing through I2. This thing is also possible, so when you see it, don't panic. And there's another example. Okay, sometimes it only asks you to find the current, which is like this. So now let's quickly see the value of I0 or I naught or I0. What is the value of I naught? Actually, I naught it's equal to I3 because you see both of them passing through the same direction. So in this case, you just do the mesh analysis, find the value of I3, and I3 will be equal to I naught. In this scenario, you cannot find the value of I3 without finding the value of I1, I2. So sometimes he gives you like find the value of I naught, and sometimes you feel happy. You say that, oh, I don't have to use mesh analysis, but actually you have to use it, okay? So sometimes solving a lot of problems can enlighten you to things that you couldn't imagine to see it, okay? Just like in the previous problem, I believe, I'm 100% sure that some of you thought that this scenario is impossible. So solve these guys, okay? They are very beneficial, okay? As we see here, we have a super mesh here because this current source is between two meshes, this mesh and this mesh. Hopefully you enjoyed this tutorial, and I will upload this file in the description again and download it, solve it, or you print it on if you don't have an iPad or any tablet, print it and solve it. This one is very beneficial, and I will write the reference book in the description. So if you want to download it and solve problems. And to conclude, that's it for today, and see you soon in another tutorial. Goodbye.